This gadget is a balance. You can see that it is in balance now. This is a magnet. The magnet has no effect on the balance. The copper strip around the edge of the balance is connected through these pivot points to a battery. When the switch is closed, electric charges will flow through this circuit. The flow is shown by this meter. The magnet has no effect on the balance until the switch is closed and electric charges flow through the copper strip at the end of the balance. The magnet affects the balance only when there is a current in it. It affects the balance with enough force so that you have to put weight on the other end, in this case some sugar, to make it balance again. Here is a magnetic needle removed from a compass. It can be affected by another magnet. Let's see what effect an electric current in a wire will have on the magnetic needle. Again, magnetism and electricity seem to have some connection. Notice that when the current is turned on, the red end of the needle swings toward us. With the flow of current reversed, the needle swings the other way. Here's a piece of iron. As you can see, it's not a magnet. But perhaps you know what will happen when we put the iron inside a coil of wire and let electric charges flow through the coil. An electric current can produce a magnetic effect. In fact, this is called an electromagnet. An electromagnet acts as a magnet only as long as electricity is flowing through it. Here's an electromagnet powerful enough to pick up a load of steel bars. Electric currents can produce magnetic effects. Now let's see if the opposite is true. Can magnets produce electric currents? This coil of wire is not connected to a battery. It's connected in circuit with this meter, and that's all. There is no current in this circuit. There are electric charges in the wire and the meter, but nothing is making them move. And there is electric current only when electric charges are moving. Watch the meter when this magnet is brought close to the coil. There were electric charges flowing through that circuit for a moment. There again, but in the opposite direction. Somehow the magnet is making the electric charges in the circuit flow, but only when the magnet is moving. If we keep the magnet moving, we're able to generate a fairly continual current in the circuit. What's making the headlight burn? Is there a battery? No, there isn't any battery in this motor scooter. That's odd. The lights don't go out in a car when you turn off the engine. What makes the electric current that lights this headlight? The answer is magnets. The magnets are inside here. This is a magnet. When the motor is running, it makes these magnets move past the coils of wire. As they move past, the magnets cause the electric charges in the coils to move, producing an electric current. Just as we are doing here. Here's another device that can be used to produce electric current. In this one, the magnets don't move. Instead, the coils move in relation to the magnets. When the machine is cranked rapidly, it produces enough electric current to light a bulb. Machines that produce or generate electric current are called generators. You can generate electric current either by moving coils in relation to magnets or by moving magnets in relation to coils. We've already seen that a coil or wire with a current running through it can produce magnetic effects. Could we use this coil instead of a permanent magnet to produce an electric current in the other coil? Let's see. Of course, we could generate an electric current without moving the coil at all. What's generating current now? The nails are affected by the electromagnet, but the effect is weak. If we move the electromagnet closer, the effect is stronger. When there is a current in the coil, the magnetic effect is strong. When there is no current, the effect is weak. In fact, there is no magnetic effect at all. By opening and closing the switch, we are making the magnetic effect weak, then strong, then weak, then strong. In other words, turning the magnet on and off has the same effect as moving it in and out. So we're producing an electric current in this circuit simply by turning the electric current on and off in this circuit. Water power is used to turn the generators in the powerhouse of this dam. These huge generators work on the same basic principle as this generator. We are producing an electric current here by moving a magnet. And basically the same thing is happening here. Inside these generators, magnets are moving past coils producing electric current. They are producing a great deal of it, enough to light a city.